Hi, I'm Tina from Prep 101. In this video, we're going to talk about distance, scalar multiplication, and adding and subtracting vectors. And those are usually about 1 or 2 questions on the first exam. Okay, let's get started. So first of all, for distance, it's a pretty easy formula in order to calculate the distance. If we have vector u is u1, u2, and u3, and vector v is v1, v2, and v3, then our distance from u to v is the square root. And what we do is we subtract the components and then square them. So you can start with u or you can start with v. It doesn't matter which one you start with. I always start with the second one, just habit. So I do v1 minus u1 in brackets squared plus second component v2 minus u2 in brackets squared, and then third component v3 minus u3 in brackets squared. So I'm always starting with the same vector and ending with the same vector. So if I give you, let's say vector u is -1, -2, and 3, and vector v is -2, -1, and 1, and vector w is 4, -1, and -2, then we can calculate the distance between these vectors. So first of all, I'm going to do the distance between u and v. So I'm going to start with v, and I'm going to subtract the components here. So we take the square root. Always put your square root on first, just so you don't forget. So the first component of v is -2 minus the first component of u. So -2 minus -1 minus the negative would become +1 squared. Middle component, -1 minus -2 is -1 plus 2 squared. And the last component is a 1 minus 3 in brackets squared. And so we have -2 plus 1 squared is -1 squared is 1. -1 plus 2 is 1 squared is 1. And 1 minus 3 is -2. -2 squared is +4. Just make sure that any negative squared is always a positive. So 4 plus 1 plus 1, we would get √6. And we just leave our answer like that. So if we want the distance, let's say from v to w, we've got vector v here, vector w here. So go ahead, pause the video, and see if you can work out your distance between v and w. Okay, so we've got square root. First component of w is 4 minus first component of v is -2. So 4 minus -2 is 4 plus 2 squared plus second component of w is -1 minus -1. So that's +1 squared. And last component of w is -2 minus last component of v is 1 squared. So we've got square root. And here we've got 4 plus 2 would be 6. So we've got 6 squared. -1 plus 1 is 0 squared. And -2 minus 1 is -3 squared. Again, any negative squared would be a positive. So we've got 6 squared is 36 plus 0 plus 9. And our answer is √45. Now in this course, they don't tend to rationalize. I'll show you how to do it just in case they throw it on the exam this year. You never know what new things they're going to put on, but generally they would leave the answer as √45. Now, if you want to rationalize, if you're looking for √45, to break this down, you're looking for a perfect square. So a number that you can take the square root of evenly in your head without any decimals. And so we can take the root of 9. And 9 times what is 45? 9 times 5 is 45. And then we do the root of 9, because that's the one we can do in our head. Root of 9 is 3, and so 3√5 would be our answer. And that's if we had to rationalize, which again, they don't tend to ask you to do, but it's possible. Scalar multiplication is another fairly easy topic. So in order to do scalar multiplication, to multiply a vector by a scalar, we just multiply each component by that scalar. So we'll just write down to multiply a vector by a scalar, multiply each component by that scalar. So, for example, if u is -1, -2, 3, and we want to find 3u, so 3u would be 3 times every component of u. So think of distributing the 3 through. So 3 times -1 would be -3, 3 times -2 would be -6, and 3 times 3 would be 9. If we had to do, let's say, -2u, then we have -2 out in front of each component. So multiply that through, and what would you get here? So -2 times -1 would be 2. -2 times -2 would be 4. And -2 times 3 would be -6. And keep in mind, when you multiply by a negative number, your new vector moves in the opposite direction. So when you multiply by a negative scalar, negative number, the new vector moves in the opposite direction of the original. And let's do one more. If we have vector v is -2, -1, 1, what would 5v equal? So pause and calculate 5v, and then you can check your answer. So 5 times vector v here would be 5 times -2 would be -10, 5 times -1 would be -5, and 5 times 1 is 5, and that's your new vector. Okay, so now we're going to look at adding and subtracting vectors. So for addition and subtraction of vectors, so here we're just going to add the corresponding components. So here we add or subtract corresponding components. So numbers in the same spot. So we add the first component of u with the first component of v, the second component of u with the second component of v, etc. So if we have our same vector u here, -1, -2, 3, and our same vector v that we've been using, -2, -1, 1. If we want to work out u plus v, we have -1, -2, 3 plus -2, -1, 1. And so we add the numbers in the same spot. So the first component, we have -1 plus -2. That would be -3. In the second component spot, we have a -2 plus a -1. So -2 plus a -1 would be a -3. And in the third component, we have 3 plus 1 would be 4. And so our new vector is -3, -3, 4. And if we do v plus w, v is -2, -1, 1. And w, this vector w is 4, -1, -2. So go ahead, pause the video, and add those two vectors and see what you get. So the first component, we have -2 plus 4. -2 plus 4 would be 2. In the middle component, the second component, we have -1 plus -1, and that would be -2. And in our last component, we have 1 plus -2. 1 plus -2 is -1. And so that would be our v plus w. So usually the first question on the exam is typically either a distance or an adding, subtracting vectors, or a magnitude, which will be in our next video. But sometimes it'll just be something like, 3u minus 5v, or something like that. So let's calculate that next. So we've got here 3 times vector u minus 5 times vector v. We're going to use the same u and v we've been using. So 3 times -1, -2, 3, minus 5 times -2, -1, 1. So here we're just combining the scalar multiplication and the adding and subtracting. So here we would first multiply the 3 into all of u. So 3 times -1 is -3. 3 times -2 is -6. 3 times 3 is 9. Now you have two options here. You can multiply the 5 through and keep it subtraction, or you can multiply the -5 through and change it to adding. If you multiply the -5 through and put it as subtraction, then you'd be wrong. So you have to either keep it as subtract and just multiply by 5, or I like to change it to plus and then multiply the whole -5 through. And people tend to make less mistakes with adding. So -5 times -2 would be +10. -5 times -1 would be +5. And -5 times 1 would be -5. And then we're back to an adding of vectors question. So we have -3 plus 10 here would be 7. In the middle component, we have -6 plus 5 would be -1. And in our last component, we have 9 plus -5, which would be 4. So our final vector is 7, -1, and 4. So I'll give you one more to try here. So let's do -v plus 3w. And I'll write down what our vector v and w are again for you. V is -2, -1, 1. And w is 4, -1, -2. So go ahead, hit pause, and work that out and see what you get there. So we multiply them, this is like a -1, so we multiply the -1 into that vector. So -1 times -2 is 2. -1 times -1 is +1. And -1 times 1 is -1. And then we multiply the 3 through to each component. 3 times 4 is 12. 3 times -1 is -3. 3 times -2 is -6. And then we're adding components that are in the same spot here, so corresponding components. So the first component, 2 plus 12, is 14. In the middle, the second component, we get 1 plus -3 is -2. And in the third component, we have -1 plus -6 is -7. And that's our final vector. So something we'll talk about in prep are properties of vectors, and they'll say, which of the following is true or which of the following is false. So here's a list of properties that we will be going through during prep. I'll just talk about them briefly now. So you can add vectors in any order, okay? So u plus v and v plus u are equal. And that's because, of course, if we have 1, 2, 3 plus 3, 4, 5, if we add 1 plus 3, we would get the same answer as if we added 3 plus 1. So the order there doesn't matter. This says you can switch the order with 3 vectors, okay? This one says 0 plus any vector is the vector. So of course, if we add all zeros, we take 1, 2, 3 plus 0, 0, 0, we're going to get the vector 1, 2, 3 back again. The fourth one says if we add the vector to the opposite of the vector, so that's something like 1, 2, 3 plus -1, -2, -3. If we add two opposites, then we're going to get the 0 vector, which is all zeros. So when you see a 0 with a vector sign, that means the 0 vector. In R3, that would be 3 zeros. Cu is a vector in Rn. That just means if you start out with a vector in R3 and you multiply it by 5, let's say, then 5 times u, if u is 1, 2, 3, then 5 times u would still be in R3. So if it starts out in R3 and you multiply it by a constant or a scalar, then it would still be in R3. Number 6 says if you take something like 2 plus 3 times a vector, you can distribute it. You can say that's 2u plus 3u, which of course we know 2 plus 3 would be 5u in the end. Same thing with number 7, we can distribute the c through. So if we have 2 times u plus v, we can say that that's 2u plus 2v. And number 8 says that 1 times any vector is just the vector. 9 says -1 times a vector is negative of the vector. And number 10 says 0 times any vector is a 0 vector. So during prep, we'll talk about lots more properties and how they come up on the exam, on exam questions. I hope you found this video helpful. If so, see more videos in this playlist. Don't forget to join the Facebook Study Hub. Use the link in the video description box. Also, I hope to see you at my prep sessions, where I'll show you lots of tricks on how to ace your exam. I'll go through every problem that you need to solve, and you'll solve them with confidence by the end of my prep sessions. Many of our prep sessions are free, so go to prep101.com now for more details and to sign up.
I hope to see you soon. Take care. Bye.